first things first, go ahead and, what do you got?
10.1?
10.2.
I'm already on it.
Alright, start talking about circles and how we're gonna find their area. We're gonna talk about their radius and their diameter and their circumference. Alright, so the first thing that I wanna look at is the notebook section of it. It says area of a circle, okay? The area of the circle is the product of pi and the square of the radius. Alright, what that means in algebra is, let me grab my marker. It's going to be area equals pi
Plus
r squared. Alright, that means pi times the radius squared gives you the area of the circle. So let's look at example 1. Example 1 says finding, well, first of all, let's look at circles just in general and let's label, let's get some labels down on some things. And you might want to get this in your notebook if you don't have it or if you don't know it. Alright? Grab a couple different colored markers here for different things. Obviously, I'm not the best circle drawer in the world, but bear with me. Alright, I have a circle. Now, the outside of this circle around the whole thing is known as what? What do we call that purple line? If we're just talking about all around the circle.
radius.
That's not the radius.
Plus the circumference.
That is the circumference. Okay? Good. Now, with my, we use really blue this time. With my blue marker, we'll pretend this is a straight line across my perfect circle that I've drawn. And that is known as what? This is the diameter. Okay? Now, black here. As we work through this section and this chapter, it's going to give you a middle point, and then it's going to give you this line. Okay?
Okay.
So what would this black line be called? The only thing left is called the radius. All right? So when we go to define these things, we have circumference. What's a good definition for circumference? What's going to be a good definition for circumference?
The outside of the circle.
That's good enough for me. Outside of a circle. Good. All right. Diameter. What would be a good definition for our diameter?
Inside line.
I would say a line straight across a circle. Now let's look in the book to see if we need to change that. Okay. So turn your book all the way back to page 290. 290.
6, Okay.
290. It tells us that the diameter is the distance across the circle through the center. So a line straight across the circle, we should probably change it and say through the center. A line straight across a circle through the center. That's good enough for me. All right. Last thing we need to do, we need to get a definition for our guy over here. Radius. What would our radius be? Okay. Let's use the book. All right. Let's do. Well, this is what the book says. Let's maybe we could maybe tweak it a little bit or come up with our own that's better in our words, or we might be able to use this one. The radius says it's the distance from the center to any point on the circle. So the distance from the center to any point on the circle. So as long as that's my center, I could go here for my radius, I could go here for my radius, anywhere, right there is the radius, okay?
Center out, maybe?
I would say, if you're okay with it, I'll just use the books. I'd say the distance from the center to any point on the circle.
Distance from
Okay? One thing that's going to help us remember the radius, and we'll just make a little blurb or a little note of it under the definition, is the radius is always going to be half of the diameter. So, I'll do a little star right here. Always half of diameter. All right?
Yep.
Okay? So now we have those three things. So if we can turn back, you're already there, to 10.2. All right? Talked about the area of the circle. So if we're trying to find the area, it's pi r squared of any circle, all right? They're going to give us a lot with the radiuses. On example 1, right off the bat, it says, find the area of the circle with the diameter of 10 inches, all right? If the diameter is 10 inches, the radius is going to be 5 because it's always half of the diameter, all right? So we have our formula right here. We have our area equals pi r squared. We are going to use the number. Let's talk about pi before we start anything. That's one thing I forgot. Pi, do we know anything about pi? Have you ever heard of this number pi? Have you ever seen the symbol for pi? Okay? This is the symbol for pi. What do we know about pi? Pi is going to equal 3.14. And this is a number that continues on and on and on and on with decimals that never repeat, and it just keeps on going and going. Not never repeat, but there's no pattern to it. It just keeps on going and going and going and go. Dang it. it's still going, so hopefully it is.
Yeah, it's still moving.
Okay.
Surprisingly, I can actually read it from over here.
Yeah. So pi is always going to equal 3.14. That's the number we could use. We could do the fraction 22 over 7. I'm not a fan of that. I'm not about that action. I'm about keeping it decimal.
Harder.
Yeah, I would say so. Okay. So we're going to use 3.14 for pi, and we decided our radius is going to be 5. So all we have to do is plug in these numbers. We're going to go 3.14, and we decided half of 10 is 5. So that's going to be times 5 squared. First thing we do in our PEMDAS rules, we do parentheses, exponents. So we got to do our, we don't have any parentheses, so let's go ahead and do our exponents. 5 squared equals 25. I take 25 times 3.14. I'm sure you need a calculator for that. I know I would.
$78.5.
78.5. 78.5. Now we're finding area. We talked about this yesterday. When we label this 78.5, what label are we going to use?
We would have to use square.
We'd use squared. What's the dimensions they give us? Inches, okay?
78.5 inches squared.
Inches squared. That's what we always have to do the units squared.
And if it has no unit, then we have to put units there.
Units. Perfect. Good job. Good memory. All right. Now, we did that part of it. Example 2, much like the first one, all right, we're going to find the radius of a circle. All right. So, it says, find the radius of a circle that has the area of 530.66 feet squared. So we have this formula, all right? So let's come over here. We have this formula. And it's area equals pi r squared. All right? When we read our problem, what does our problem tell us?
Isn't it example 2?
In example 2, what does our problem tell us? What information can we plug into this that we read from our problem?
We could substitute 530.66
For A, 530.66 goes in our A, and then we finish the rest of it equals pi r squared.
And then pi is 3.14.
Okay, so then we'll substitute 3.14 in for pi. All right, now
On this problem, we're trying to find the radius, so instead of actually doing the problem, we would divide.
you're right, because if I'm trying to get, let's say if I have 10 equals 5x. To solve this problem, to get x by itself, we divide each side by 5, right? So divide each side by 5. That leaves us with a single x over here equals 2. All right? So we want this r by itself, much like we wanted this x by itself. All right? So we're going to divide each side by what did you say?
3.14.
3.14. Both sides, 3.14. These sides cancel out. You're my calculator man. Let's see if I have a calculator that I can double check you on.
169.
What'd you get there?
169.
169, he said. Okay? We'll roll with that. 169 equals r squared. Now this takes us back to the last chapter.
Square root.
We square root it. If I square root one side, I must square root the other side. That leaves me with a single r on the right, and then the square root of 169 is?
Sin error.
What is that?
Sin error. Sorry.
Oh.
It's not working right. It's not doing it. Pretty sure I'm putting it in right, but I don't know. I don't know how to use calculators.
There. Oh, on this one you just have to put the other side of the parentheses for whatever reason.
Oh, okay.
And then there you go.
That makes sense.
And then so our radius of this circle
It's 13.
is 13. Is there any way we could check ourselves to make sure we were right?
Couldn't we do 13 squared?
Okay, so we'll substitute this 13 back in for r. Okay, we know our a is, let me erase this.
We would do 13 squared, and then we should get 169. 169 times 3.14.
Okay, so we'll keep our 530.66 equals, and then you said if we take pi and then r squared is 13, 13 squared. So 13 squared you said is what? 169 times pi equals 53066. 169 times pi.
I didn't even have it on. Five three 0.66.
So 530.66 equals 530.66. I believe our radius is 13. Good work. All right. Now, on to example 3. Using the area of a circle. All right. Example 3 says find the combined area of the two face-off circles of an ice hockey rink. All right. We need to find that area. All right. It says the distance is 44 feet, and the distance between the circles is 44 feet. All right. And there is 14 feet between the circles. All right. So, the way they did this one is they did radius plus 14
Plus radius.
plus the next radius plus nothing, or did they do equals
Equals
44? Because they have the radius, and then there's a 14-foot gap in between where the next radius starts and then it ends, and then there's 44 feet in between both of them where they begin, right?
Yes.
All right. So let's solve for r here. What's our first thing that we can do?
We could do either minus 14 for each side.
Okay.
And then we could divide it by 2.
Okay, because r plus r equals 2r. So I divide by 2 then to get my single r. Then r equals 15. So my r equals 15. Now I can go and I can start putting, I know my r. What's my equation that I'm going to use?
Area equals pi r squared.
Okay, so area equals pi. Now we'll substitute what's our r?
15.
15 squared. All right. So what's 15 squared?
15 squared is 225.
225
I would have been late.
times, substitute, what number do we substitute in for pi?
3.14.
3.14. That's going to equal our area.
$706.5.
Okay. 706.
700.
706?
Yes.
Okay. Sorry about that. 706.5. All right. Now, it asks us to do 2 circles, right?
Yes.
All right. So what do you think we need to do with this number? That's the area of 1 circle. What can we do with this number to find the area of 2 circles? Times it by 2. Multiply it by 2. Whatever you want to say. I'm not going to be a stickler about that.
706.5 times 2. 14.
1,413.
Because
And
I'm
then
so smart, you can do your shutdown.
Oh.
Wake up.
All right. So 1,413. Good. And then what can we label that? What's the units that they used?
They use feet.
They did
So
use
the-
feet.
1,413 feet squared.
Feet squared. All right, my man. I think you're ready to rock on this. Okay. So let's go with, on the next page, 488. Let's do 2 and 4. And then let's do 10, 11, 14, 15. 2, 4, 2, 4, 10, 11, 14, 15.
4, 10, 11, 14. Is that it?
Well, let's get those done first, and then we'll talk about it. If we get those done, we won't have much time left.